Before actually starting on graphs, we are going to sense the importance of graphs in today's world because graphs are everywhere. Graph is pretty prime topic of discrete mathematics, and that's why there are literally thousands of algorithms on graphs. There are so many libraries on graphs, and even there are so many databases on graph theory. So graphs are having so much importance that they are creating magic without us realizing. Whether you are using Twitter or Facebook or LinkedIn, there are graphs everywhere to make this world a small place. You're friends with someone on Facebook, you are going to get a suggestion to be friends with another person who is already friends with that person. How this practically happens? Behind the scenes, there are graphs to do this. Wherever there are relations, there are graphs, and wherever graphs exist, they uncomplicate many big ideas. Because every single thing in this world can be said to have some kind of relation with the other things. Even the whole world can be represented as a huge graph. Let's take a few famous examples to explore graphs more. The famous Twitter example, which is slightly different from Facebook example in sense that if a person follows someone on Twitter, it's not necessary that the other person must follow him or her back. It's up to the person if he wants to follow him or her back. For example, a guy, Dustin, follows Mike, Mike follows Dustin, Dustin follows Max, but Max does not follow him back, whereas Mike and Max both follow each other. So here nodes or vertices are the Twitter users, and all the vertices are connected with relationships. And to follow somebody is the relationship here. Now recall the separation degree of LinkedIn. It says that this person is one connection away from me. I'm connected to somebody who is connected to this person. And if the separation degree is 3, this means I'm 2 connections away from this person. I'm connected to somebody who is connected to a person who is connected to this person. So it's a pure relationship game here. These are just very small portions of huge graphs of these social networks. So these were some of the social side examples. Let's have a look on few more. Graphs are used to model molecule structures for computer processing where atoms can be treated as vertices and bonds between them are represented as edges between them. These structures are created based on properties of compounds and are taken for analysis and processing. This can be used to study the structure of molecules and to check similarities between the molecules. Graphs are extensively used for the analysis in biological networks. The components of the system and their interactions is distinguished as network, and they are normally represented as graphs where a lot of nodes are connected with thousands of vertices. Few of their biological applications are they are used in protein-protein interaction networks, they are used in regulatory networks, they are used in signal transduction networks, they are used in metabolic and biochemical networks, and other than these, they're used in language processing, they're used in maps, for example, Google Maps and other kind of maps. They are used in hypertext. When we browse the web, we encounter documents that contain references or links to other documents, and we move from document to document by clicking on the links, right? So the entire web is a graph where the items are documents and the connections are links. So graph processing algorithms are essential components of search engines that help us locate information on the web. So these were some of the examples from the immense space that graphs cover nowadays. But believe me, there are a lot more applications of graphs.